Good evening student. Today I'll discuss about electric field lines and their characteristics. ପୂର୍ବରୁ ଆମେ କିଛି characteristics ପଢ଼ି ନେଇଥିଲେ କିନ୍ତୁ କିଛି ଇଲେକ୍ଟ୍ରିକାଲ ତ୍ରୁଟି ଯୋଗୁଁ ତାହା ଅଧା ରହିଯାଇଥିଲା। ଚାଲ ଆମେ ପୁରା କରିବା। କ'ଣ concept is the lateral force between two lines of force indicate there is a electrostatic force of repulsion. Indicate there is a electrostatic force of repulsion between two similar charges. Suppose this is the plus q charge and this is the plus q charge. Both charges are generate electric field lines. Like that. These are the field lines. Due to similar type of nature charge, they represent field lines. That charge sending lines of force in that way. Sending in that way, but when the lines of force which is come in contact to another lines of force of another charges, then there is a lateral force in between them. Suppose this is the lines of force, this is the lines of force of two charges. There is a force is here, that is the lateral pressure or lateral force due to that lines of force, and there is a force is here due to that lines of force. That force represent is a lateral force or lateral pressure. Due to lateral pressure, they are bands like that. They never interact with each other. They try to interact, but they never interact with each other. द्वितीय कथा सेमाने चेष्टा करती सेमाने कौन होती सीधारे जीवाकू लाइक दैट ए डायरेक्शन जीवाकू सेमाने चेष्टा करती किंतु चेष्टा करती किंतु सेमाने निजर चार्ज को दूरे नियंती जो जगह थिले पूर्वरु चार्ज जाक से चार्ज को सेमाने दूरे नियंती जो द्वारा कि तमे कौन हो पारिबे सीधा हो पारिबे सेति पई सेमाने कौन करंती तांकर सोर्स चार्ज को जेतिकी डिस्टेंस रे थिले से दीटा चार्ज को सेमाने किछि दूरता दूरे नियंती आमे भाबुचे जे दीटा जाक सिमिलर चार्ज कौन करंती सेमानक भितर फोर्स जनरेट करंती कि प्रकार फोर्स ऑफ रिपल्शन ओके and that is the force lateral force is here. Okay, now there is no electric field in between the two charges. In that region there is no electric field or electric field lines. Okay, so that is all about lateral force between two lines of force indicate there is a electrostatic force of repulsion between two similar charges. जदि हमें देखिबा there is a force of attraction between two opposite charges which experience a kono there is a lengthwise contraction पूर्व हमें पढ़थिले नेक्स्ट टॉपिक रे कोन so which positive charge, this is the positive charge, this is the negative charge, which sending lines of force in that way and they are moving toward the negative charge and that also sending in lines of force toward the negative charge. So in that way that is the similar type of lines of force are generated by the two charges. These lines of force experience a force that is force behaves as a lateral force. What? Lateral force. Due to lateral force, they are in curve in nature, so wider. At the middle point, they becomes wider, like that, wider. And end of the surface of conductor, they becomes perpendicular. These lines of force always perpendicular to the surface of conductor, but at the middle region, they becomes, the lines of force behaves as a wider. Okay, due to concept of the lateral force between two lines of force, which indicate there is a positive charges, two positive charges. Okay, this is the concept of lines of force. Next concept is field lines. Field lines link to the charge is equal to 1 by epsilon naught times. That means 1 by epsilon, that is 1 by epsilon equal not equal to 1 by 8.854 into 10 to the power minus 12, और आम लिखिपर 1 by 8.854 into 10 to the power 12. This is the number of lines of force, that is huge amount of lines of force which are originating from the positive charge, and they are also entering toward the negative charge. Okay, these are the huge lines of force. Okay, that is all about overall concept of electric field lines and their characteristics. Okay, then ଆସିଲା ଯିବା distribution of charge. ଏବେ ଆମେ ପଢ଼ିବା electric field lines due to distribution of charge. electric field lines କ'ଣ, ତାକୁ ଆମେ distribute କେମିତି କରିବା, distribution line of charge, lines of charge ରେ ଆମେ କେମିତି distribute କରିବା ତାହା ଆମେ ଜାଣିବା। ତ ପ୍ରଥମେ ଆମେ କ'ଣ କରିବା, ଗୋଟେ ପଏଣ୍ଟ ଚାର୍ଜକୁ ରିପ୍ରେଜେଣ୍ଟ କରିବା। ए पॉइंट चार्ज जो ए पॉइंट चार्जटा कौन हो गोटे प्लस क्यू चार्ज हो जो इलेक्ट्रिक फील्ड लाइन्स हम कौन हे अवे फ्रॉम इच अदर हे। ओके, so this is electric field lines. Okay, and they goes radially outward due to positive point charge. Point charge. Then asla negative charge to them, a negative charge naba. So they are inward. So radially inward due to negative point charge. Line charge. So this is the line charge. Here, this is the line charge. That line charge contain many number of point charges. So these point charges are similar in nature, though, so they produce a lines of force. These lines of force are parallel, like that. And they go radially outward. Because why they are parallel in nature, the lines of force? Because these are the similar type of charges which are present, so they produce lines of force. That lines of force are repel each other, so they becomes parallel in nature. Lines of force are parallel in nature, like that. But edge of the line charge the lines of force behaves as a radially curl. କ'ଣ ହେବେ? Radially curl. Why they becomes radially curl? Because in below region of the line there are number of charges here, so that charges sending lines of force, that lines of force and that lines of force are repel each other, so that they becomes radial, because there is no charge which is present on the above the line, so that they could not repel by the above charge, the sending lines of force, but they are repelled by the lines of force which are generated by the point charge. The same thing is happens in the below region. ओके तार अर्थ है जदि आम देखा एंड रिजन रे ए चार्ज जाक तले जी चार्ज जाक से कौन करेंगे लाइन्स अफ फोर्स छाड़े ए लाइन्स अफ फोर्स जो से कौन है ये जो पॉइंट चार्ज जो लाइन्स अफ फोर्स छाड़ती से कौन है आंक द्वारा रिपेल हो जो द्वारा कि कौन हो रेडियली कर्ल इन नेचर हो same thing is happens on that below, so that is radially curl, but they are uniform lines of force radially curl. Then asla कंडक्टर जदि आम कनसीडर करिया गोटे कंडक्टर को नवा ए कंडक्टर कौन हुए ऑन द सरफेस रे चार्ज जाक रुहती सरफेस रे चार्ज जाक रुहती ओके कारण these charges are repelled by the source charge, okay, and they could not move away from the surface of conductor because there is air resistance which is present. That air behaves as an insulator, so they oppose to the charge. That's why all the charges are present on the surface of conductor. They are sending electric fields or electric field lines like that. Okay, like that, and they becomes radially outwards. But inside the conductor there is the absence of electric field intensity. Why? Because electric field lines and electric field intensity is a parallel in nature, because electric field intensity is a vector quantity. When these lines are entering toward the surface of inside the surface of conductor, then they are cancel out each other. Suppose this lines of force in that way, this lines of force in that way, this lines of force in that way, that lines of in that way, so there is no lines of force inside the conductor. That's why electric field intensity inside the conductor is 0. Next asila plane sheet. If you represent a plane sheet, another plane sheet is here, and they are parallel to each other like that. Suppose that plane sheet contain number of positive charges. They are uniformly distributed on that surface like that, and that contain number of negative charges. They are also uniformly distributed on the surface of plane sheet. That means these are the charges uniformly distributed so that that charge repel by that charge. So they moves in that way. That charge also move in that way. That charge also move in that way. Now another charge like that which is come in contact, then also it experiences a force of repulsion. That's why all the charges which are placed on the surface of plane sheet, they are stay out at a particular point because each charge contain force is zero. प्रत्येक charge force कौन है zero. Therefore net force below becomes balanced on that surface of plane sheet. Same thing is happens on the negative charge. So that's why the electric field lines are moving parallel in nature from one plane sheet to other plane sheet, because the charges are placed uniformly distributed on the surface of conductors. But near the edge of the plane sheet like that, that is plus and that is the minus. We know in line charge, end point of the lines of force becomes radially curl in nature. Same things happens on that plane sheets where the charges are present near the edge of the conductor. So they generate a line of force. That lines of force are curl in nature. Same thing happens in the below charge. Okay, so curl uniform. This is the overall concept of electric field lines due to distribution of charges. Okay, thank you.